Hi everyone, today we're going to be looking at init function and how it's used in functions inside of classes. So here we go. Okay, so over here you can see another program. At the top as usual is what we're going to do today, then the rules, and lastly the program. So today we'll be looking at the init function in classes. When you use the init function and run it, it will always get printed. So here I set class tiger. Then def init self. So self is always the first parameter in a function in classes. So I can write self and some other parameter, but you shouldn't be writing it like this. The self should always be the first one. Then def init basically means that whenever I call this, so when I set amber equal to tiger, then amber.color. So I'm just gonna take this away. Right, now when I run it, it says tiger always has stripes. That's what I set under the init def, or the init function. And if I call the color, so color is just color. Some tigers are orange and black while others are white. So I have to call this one. But it automatically prints this one. It automatically prints the init function. So that's basically what I mean, that when you use init function and run it, it will always get printed. So it's like you have to print it, so it's forced to get printed. So that's basically what I mean. Then the class tiger is nothing without an object. So the class tiger is nothing without an actual tiger to represent it. It's like a blueprint for a building. The blueprint is nothing without the object, or the building in this case. So tiger is nothing without an actual tiger to represent it. This class is basically like a blueprint for the actual tiger. So in here, so everything inside this class is a special type of function called a method. So this entire thing, so the class plus the method, that's the entire blueprint for the object a tiger. So we can talk about white tigers in this case. So here we're talking about tigers in general, but if we're talking about white tigers, so if I had called this white tiger, then we would have obviously put different methods in it. But what I'm trying to say is that you need an actual white tiger object to represent it. But if we talk about an animal that's extinct, like dinosaurs, then if I say a class dinosaur, then we wouldn't have an object to represent a dinosaur because dinosaurs went extinct. So only the blueprint is left for dinosaurs. There is no actual dinosaur object. If we say class dogs, then you can just pick up any random dog, like say a poodle, then that falls under class dog because poodles are dogs. And obviously we'd put different methods inside it. But without an actual dog, this is just a blueprint. Same goes for extinct animals like mammoth or dodo birds. So mammoth is extinct, but if we write something like this, that becomes its blueprint. For dodo bird, it falls under a bird class, and you write a method for it, but it's extinct. So that's. And if we look at something else, like say a society or apartment building, so apartment buildings, so we could say apartment buildings have towers, they can have floors, they can have flats or houses. So in an apartment building, all of those things are common, so we would put that under the init method. But then without an actual representation, or without an actual apartment building with towers, floors, and flats or houses, it's nothing but a blueprint. So same here, so tiger. So here I've said init, here I put more information like the DA of color, but this entire thing is a blueprint. So classes are structured like hierarchies, and over here we're talking about like an apartment building. Then in an apartment building, so we've got like apartment buildings have, so if you're talking about tower apartment building, so not all societies really need like houses, like individual houses. Some are like towers. So if we're talking about tower buildings, so all of them have towers, all of them have floors, and all of them have houses. So this is everything in common. But if I say class building, then all of this is simply a blueprint, unless there's an actual building to represent it.